Okay, everybody, today we are continuing on with lesson 10.1. So in our last video, we did lesson 10.1 where we learned to make scatter plots and decide if those scatter plots had a positive correlation or a negative correlation. But we're going to take that a step further today, and we are going to go into a little bit more detail about some things you can do with scatter plots. So what we're first going to learn to do today is how you can make a line of fit for a scatter plot full of data. So the section that we added here, right below where you left off on lesson 10.1 notes previously, is fitting linear functions to data. So there's kind of a bullet point list here of the steps that need to be followed. First things first, you have to take the data that you've been given and draw a scatter plot with it, like we learned in the previous video. Then what you're going to do is you're going to take a ruler and you're going to draw a straight line through the middle of the points. What you have to make sure of is when you go through the middle of the points, you don't want your ruler just going through thin air and hitting absolutely nothing through the middle. You want to make sure that you hit at least two of the points on your scatter plot when you draw your straight line. Then you're going to need to find the slope of the line you drew. To find the slope, you're going to use those 2 points that you hit and use the slope formula. So the slope formula, just a review from a few chapters ago, is y2 minus y1 over x2 minus x1. And then, once you have the slope, you can finish getting the equation because you're going to need the y-intercept, the b. So you'll have the m, you need the b. You're going to plug your slope and a point into y equals mx plus b and solve for b. And then you'll have your m and your b, and you can write your equation in slope-intercept form. So what we're going to take a second to do now is we're going to look at page 359, number 7, because it's almost exactly like what you guys are going to see in your homework. So I'm going to zoom in on this a little bit, and I'm going to pull the book over here to page 359. And what you're going to see as your directions for this section on page 359 is they're going to say, make a scatter plot, determine a line of fit for the data, and write the equation of your line. So that's what we're going to do using the data right here from number 7. So on number 7, okay, on my x-axis, I need to have my weeks after opening, so I need a line that goes 0 through 5. And then on my y-axis, the weekly revenue that they're bringing in as far as dollar amounts goes everywhere from 1,050 to 3,600. So I think what I would do here is put a break in my graph and just start at 1,000 and then find something reasonable to count by that would get you up to include numbers this high. So I'm thinking counting by 500s makes a lot of sense. So if you look at the grid I already labeled out here, here's my weeks 1 through 5. And then starting at 1,000, counting by 500s. And we're just going to go through and we're going to plot each point very reasonably on the grid for the scatter plot we made here. So first point 0, 1,050 should be down here very, very close to 1,000, just not right on the line. Then we have 1, 1,700. Put that about there. We have 2, 2,400. We have 3, 2,000. We have 4 and 3,500. And then we have 5, 3,600. And what we have to realize now is we've got our scatter plot. We can definitely see there's kind of a positive trend or positive correlation happening with my points in my scatter plot. But what we're going to try to do is draw a straight line called, fit a line to the data, make a line of fit that goes through the middle of the points the best we can. And we do have to realize that if we weren't working on this together, right, there's enough human error that we might very well pick different points if we were doing this individually. So if without technology, okay, there's kind of definitely susceptible to different human interpretations or opinions. But if I was going to try to make a line that has to go through at least 2 points here, and I tried to find something that was going to roughly go through the middle, I'm feeling like my best shot at the middle would be doing this first point at 0, 1,050, and this last point at 5, 3,600. So I'm going to draw a straight line through there, And hopefully when I pull that away, we'll kind of agree that that seems to fit through the middle of the points pretty well. And I have purposely made sure to hit at least 2 points because now I can use those 2 points to come up with the equation of this line of fit that I just drew. So my 2 points, I'm going to jot those down so that we have them clearly in the notes. Okay, the 2 points that we agreed we were going to hit were 0, 1050, and 5, 3600. So those are the 2 points that we know we've hit. I'm going to slide over here and we're going to do the work required to find the equation of this line. So first things first, if you want to write the equation of a linear function, you need a slope. So we are going to do the slope formula. Okay, if you have forgotten how that works, these are your x and y coordinates. And we just call this x1 and y1 because it's the first point. And this is x2 and y2 because it's the second point. So if we follow this formula that's written right here, we would have 3,600 minus 1,050 over 5 minus 0. y2 minus y1 over x2 minus x1. I'm going to go ahead and subtract those. 3,600 minus 1,050 is 2,550. 5 minus 0 is 5. We're going to go ahead and divide that, and it comes out as 510. So that right there is my slope. The slope of the line we drew is 510. So now that we have the slope, we need the y-intercept if we're going to write an equation in slope-intercept form. So I like to write down slope-intercept form, y equals mx plus b. This is kind of the format I'm shooting for. And then, like it says right here, you're going to plug slope and a point into this format. So you have 2 points to choose from. Choose whichever one has friendlier numbers that you want to work with. I'm going to choose this one because anything that's got a 0 in it is lovely. So my y coordinate is 1050. M is my slope, that's 510. And my x coordinate from the point I chose is 0 plus b. So we would now need to solve for b. So the reason I liked the 0 we chose is 510 times 0 is 0. And 0 plus b is just b. So b equals 1050. Now sometimes that won't happen. Like if this multiplied out to something, then you would need to subtract it from 1050 to finish solving for b, just like solving a regular equation. But here you have your slope, you have your y-intercept, so putting it all together in an equation would be y equals 510x plus 1050, and that is the equation for the line of fit that we drew for this data. Okay, so not every point falls directly on that line, but this line is a very good model for what the trend of this data does. So the whole reason that we find that useful is once you have an equation that models the data really closely, you can use it to make some predictions. So that's the last section down here on the notes. Using linear functions to make predictions. There's 2 types of predictions that we want to be able to make and know the vocabulary to go with them. They're called interpolation and extrapolation. Okay, interpolation is those predictions that are within the original data set, and extrapolation is the predictions that are outside of the original data set. So, for example, okay, we could use this and say, hey, let's predict the revenue for 7 weeks in the previous example. So they gave us data for weeks 0 through 5. But they didn't tell us what the revenue would be in week 7. Well, since this line kind of follows this continuous path, we're not going to be able to hit it right on the dot and know exactly what's going to happen in week 7 because we can't plan the future out exactly. But we can make a really good prediction that if we followed this line up to week 7, it would be a good rough estimate of what we could expect in week 7. So what you would do there is you would use week 7 and plug it into the equation you wrote. So you would do y equals 510, and then you would plug in a 7 for x plus 1050, and then you would just work that out. 510 times 7 plus 1050 is going to come out as 600 $4,620. So sorry for my miswriting there. $4,620. So we don't know exactly that that's what would occur in week 7, but based on this model, it's a really good prediction. Then when you read those questions in the homework, it's not only going to ask you to make the prediction, it's going to ask you for one of these terms. It's going to ask you, is what you just predicted an example of interpolation or extrapolation? Okay, well for this one, we would want to write down the word extrapolation, and here's why. You were given in the table in your book points from 0 to 5 weeks. So when they ask you for week 7, that's them asking you for something that is outside of the original numbers you were given in the table. It's beyond what information you were given in the table. Okay, an example of interpolation would be, okay, if they had asked you like, okay, you have data for week 3 and week 4, but what if they had asked you, where was the revenue at about 3.5 weeks? Okay, well, 3.5 weeks is within the range of numbers that they gave you in the table. You don't have a specific point for that, but it's within the 0 to 5 weeks, where 7 is outside of that 0 to 5 weeks. So that's the difference between interpolation and extrapolation. Okay, so homework that goes along with this lesson is just going to be added on to lesson 10.1 that was already started in the previous video. So all you're going to do is add 6 through 12 even, so just 6, 8, 10, and 12 off of pages 359 and 360. Okay, and what I want to talk to you guys about is we're going to look at the ones in the book real quick and kind of look at how you would set that up. What we're going to need to agree upon, if you want to write this down at the bottom of this, and we can also take a look on your homework paper, is that just like we talked about here, had we not been doing this together, we might have all chosen 2 different points to draw the line through, which means we would all get very different equations. So for the sake of grading homework tomorrow, we're going to choose that on number 6 and 8, we're going to all agree that we're going to draw our lines through the points 263 and 595. And we're going to agree that on number 8, we're all going to draw our line through 2, 8.1, and 7, 7.1. That way we should all get the exact same answers for our equations and our predictions so that this won't be a really huge headache to grade with a ton of different answers. So what I'm going to have you do is take a look at, if you look at number 6 in the book, if you did your homework for the previous lesson 10.1 assignment, these numbers should look really, really familiar. You actually already made a scatter plot for these exact numbers in number 2. So the scatter plot that you should have made for number 6, that you make for number 6, would look exactly like this one that you already did in number 2. So I went ahead and wrote it down, and I just kind of want to emphasize this point that I made on the notes that you guys just took. Okay, like I said, we need to make an agreement that everybody's going to go through the same 2 lines on their, or same 2 points on their scatter plot. So right here is 263, and here is 595, and we're just going to make the agreement so everybody's answers are the same, that everyone is going to draw their line through those 2 points, and we're going to call that the middle. So when you do your work for number 6, and yes, there should be work, you should be using the points 263 and 595 in order to find your slope and in order to find your y-intercept. So when you guys do this, this doesn't work out as pretty as the one in the notes. The one in the notes came out to that nice perfect 510 for the slope. This one won't do that. So once you do your y2 minus y1 over x2 minus x1, you will get a decimal. Go ahead and round that decimal to the 10th place and use that moving forward so that everybody should get the same thing. Okay, same thing like I just talked about on number 8. Number 8, we said at the bottom of your notes, you may have written it down, okay, or you can write it on your paper right now. But we're going to use 2, 8.1 and 7, 7.1 as your points. So it's this second point right here, and then it's the second one from the end. And we kind of agreed in class that that was pretty close to the middle. Better than doing the first and the last. That was a little bit off. Okay, so this is what you should be using to find your slope and y-intercept. Okay, once you guys have done those, numbers 10 and 12 ask you to use the equation that you got in 6 and use the equation that you got in 8 to make a prediction. So make sure that you remember that once you make your prediction, it asks you to state whether it's interpolation or extrapolation. So make sure that that gets stated along with your prediction. And that's why it was also important that we all be using the same equation to make our predictions. So everyone should get the same answers on everything for 6 through 12 evens. So go ahead and add that on to the end of lesson 10.1 homework from the previous day, and everything can get graded all together tomorrow. Good luck.